Hello guys, today we are going to learn our lesson. Our last lesson we have learned that uh, how to calculate relative atomic mass given that the mass and the respective percentage. We are given the two masses of an element and also their respective percentage. How to calculate the relative atomic mass, we have learned it. For the next lesson that we have also seen was how to calculate uh, the percentage when given the relative atomic mass and also one of the mass and its percentage, how to get the mass, the percentage of the other mass. That means they will give you uh, the last question that we have seen was they will give you the relative atomic mass, they will give you one of the mass plus its percentage. So they will also give you the other mass, but you don't know the percentage of the other mass. So how to calculate the percentage of the other mass, we have also seen it. For today, we are going to see different issues. That means we are given the relative atomic mass, the RAM. We have the RAM. We have the two masses. The masses, that's the two masses. But we don't know any percentage of these masses. We don't know their percentage. So how to calculate the percentage when given two masses and relative atomic mass? That's what we are going to see. And the last question that we have done was when given a relative atomic mass, one of the mass and it's also percentage, the other mass also given, and we don't know the percentage of the other mass. That means that the last question that we have seen, both masses they give you, and one of the percentage they give you of one of the mass. The other one they will not give you its percentage. So that one is also the one that we have seen our last lesson, and it's there in the YouTube channel. So, but today we are going to see when given the relative atomic mass and the two masses, how do you get the percentage of each mass? That's what we are going to see. Okay, let's start it. Let me rub the board. Let me clean the board. It's just like eraser. We are going to rub the way we used to rub in our classes. This is online class. YouTube is Ayman Hassan. You can subscribe if you want to learn more about chemistry form 3 mole. This is the beginning of mole. We are going to do it one by one and you will learn it a lot, inshallah, as we are together. Okay, let's now see this question. The relative atomic mass of chlorine is 35. This is the relative atomic mass of chlorine is 35.5. So calculate the percentage if the mass of chlorine are 37 and 35. So this is the masses of the chlorine, 37 and 35, but we don't know the relative atomic mass. So how do you calculate the relative atomic mass? You know the relative atomic mass 35.5. You have the masses, respective masses, you don't know the percentage. So for us to calculate, we create an equation. How do you create the equation? We will say like this: let the percentage of mass chlorine, the percentage of mass chlorine 35 or 37, let me say 37, b x, we don't know. Then what will be the percentage of chlorine mass 35, which will be what? So if you know the percentage of chlorine is always 100%, completely 100%. If one of the percentage of one of the mass, that chlorine 37, is x, the other one will be 100 minus x. Obviously the other one will be 100 minus x. We don't know both of them, but what we know that is we know that the relative atomic mass is equal to the sum of the percentage of the product of the individual masses. The sum of the product of the percentage and the mass of the individual masses. When you multiply the mass and its percentage and you add them and you divide by 100, then it's equal to relative atomic mass. So we create an equation. The equation will be 35.5, which is the relative atomic mass, is equal to the mass chlorine 37 times its percentage, which is X, we don't know, close bracket, open bracket, plus we have also chlorine 35 times its percentage, which you don't know. The percentage of chlorine 35 is 100 minus X. You open bracket, 100 minus X, then you close bracket. So this line is a little bit disturbing me. Let me clean this line first of all, okay, so that I can get enough space for this. This is X, this is X, and let me also clean it here to get enough space so that it's visible. 35, then we say times, open bracket, 100 minus X, then all of them divided by 100. Why am I doing that? 37, mass 37 times its percentage, which is X, we don't know. Chlorine 35 times its percentage, which is 100 minus X. So I'm introducing a new bracket. Why am I introducing a new bracket? The reason as to why I'm introducing this bracket is because here we have minus and here we have times, so we need to put in bracket. So let's solve this equation. So we rewrite the equation. We take chlorine, we take 35.5, which is the relative atomic mass, is equal to 37 times X, 37X, plus 35 times 100, it will be 35,500, minus 35, which is positive 35 times negative X, it will be negative 35, negative 35X, it will be negative 35X all over 100. Now when we do here, we collect like times. This 35X and this 37X are like times. We arrange the like times. Then we say 35.5 is equal to 37X minus 35X plus 37,000. I mean 3,500. I am subtracting this one and this one because they are like, both of them they are carrying X all over. Don't forget this 100 over 100. Now here it will be 35.5 is equal to 37X minus 35X, it will be 2X plus 3,500 all over 100. Now when you are here, we have here a number, whole number, and here we have fraction. We need to create a linear equation. How do you create linear equation? So you close bracket here, you also close bracket here, then here there is one hidden here, then we get fraction. So this fraction of 1 and 100, we look the LCM of 1 and 100. The LCM of 1 and 100 is 100. You multiply the LCM throughout both sides, this side and this side, to get linear equation. So times 100 here, times 100 here, the same way. Okay, when 100 is multiplied by 35.5, we get 3,550 is equal to this 100 and this 100, they cancel each other. If I use the red pen to show the cancellation, this 100 and this 100, they cancel each other. Then we get it 2x plus 3500. Then we have now linear equation. So this 3500 and 3550, this one, they are like times. Now this one we transfer to the other side, and you know it carries positive. When we transfer to the other side, it will be minus. 3550 minus 3500 is equal to 2x. Then when you subtract these two, this is what you get. If I use the upper part of the blackboard, 3550 minus 3500, you get 50 is equal to 2x. So both sides you divide by 2, you divide by 2. Then 2 and 2, they cancel each other. When I'm canceling, I'll use the red pen. 2 and 2, they cancel each other. This is by 2, 50 divided by 2. X alone is equal to 25%. Now the value that we take x was 35. Chlorine 37, its percentage is 25. So chlorine 35, its percentage, we said 100 minus x. Then we said 100 minus x. And what is the value of x? Is 25. Then 100 minus 25, which gives you 75%. So the percentage of chlorine 35, chlorine 37, and chlorine 35 is 25% and 75% respectively. And when you add that 75 and 25, they give you 100. So that's how it is. Good. Thank you for listening, and please, that's the end of the question today. Please summarize this question and understand it well.